Welcome everyone. In this video we are going to discuss about informed search algorithms. Now we have already discussed about uninformed search algorithms in the previous videos. Now what do we mean by informed search? Informed search means there will be some information already given related to the graph where you are trying to search a goal node. So some sort of information will already be given. But in uninformed search there was no additional information given. So in informed search algorithms, among all the informed search algorithms, we are going to discuss only these three: best first search, A star search, and iterative deepening A star search. In this video we will be discussing only about best first search. What is best first search? It is a greedy search algorithm. So all of you know what is a greedy search algorithm. It will try to evaluate or choose the next node in such a way that it gets maximum profit. Then it is a combination of breadth first search and depth first search. That is, it will combine both the benefits of BFS and DFS. And it uses a evaluation function algorithm to decide which adjacent node is most promising and then explore it. So some evaluation function will be there which will give the value that it takes in order to go to the reach the goal node. So based on that the next node will be explored, and it lies in the category of heuristic or informed search, as I have already told. And the data structure that it uses to store the nodes is a priority queue. So priority queue is used to store the cost of nodes. Now this is the algorithm. So this algorithm we will try to explain with the help of a graph. So here I have just shown the algorithm. Then there are few points that we should know about best first search. So in worst case scenario, the algorithm takes big O of n star log n time, where n is the number of nodes. Then its time complexity is big O of b to the power d, where b is the branching factor. Branching factor means the number of tiles that a particular node can have, and d is the depth. Then space complexity is also same like time complexity. And two important things is that properties, if we see, it is incomplete and it is non-optimal. Incomplete means what? If we are trying to find or search a goal node, it may be possible that we are not able to find a goal node. Okay, we may not be able to find out the path. So sometimes it may give the result and sometimes it may not give the result. So that is what is meant by incomplete. So and since it is incomplete, so obviously it is going to be non-optimal. Optimal means what? Providing the best solution. Since there is no guarantee of obtaining a solution, so obviously there is no point of getting an optimal solution. So it is non-optimal. Now what are the advantages? As I have told, it is a combination of both BFS and DFS. So best first search can switch between BFS and DFS by gaining the advantages of both the algorithms. So depending on the graph given, so it can choose either BFS or DFS. And this algorithm is more efficient than BFS and DFS algorithm. Now what are the disadvantages? Since it follows DFS, so it can behave as an unguided DFS in the worst case scenario. So in DFS is having the problem of getting stuck in infinite loop. In the same way, if DFS is followed, then sometimes this algorithm may get stuck in infinite loop, and this algorithm is not optimal and it is not complete also. So these are the disadvantages of best first search. Now we will see an example or graph, and with the help of it I will try to explain the algorithm. So consider this graph. So we need to find out the path from A to G. So A is the starting node and G is the goal node. So we need to find out the path from A to G using best first search. So here if you see these numbers, these are the path cost, and here you can see a table where the cost, the straight line distance is given. That is, if I want to go from A to G, depending on the straight line coordinates. So A to G straight line coordinate is how much? 40. So like that the distance is given. So this will be considered as the evaluation function based on which the next node will be decided. So this is the additional information that is given. That's why it is known as informed search. So using this information, we are going to explore the next nodes. Even though these costs are given, we are not going to consider this particular cost. We are just going to consider the evaluation function cost, which is given based on the straight line distance. So first of all, here we will be maintaining two lists. Priority queues will be maintained. So one is the closed list and another is the open list. Okay, one is the closed list, another is the open list. Okay, I have just written open this side and closed list that side. So first of all, in the open list, what we will be having initially, we will be, since A is the starting node, so we will be having node A in the open list, and in closed list it is empty. Now we are going to take out node A, and we will have to see the children of A. So who are the neighbors or children of A? B, C and D. Now which node to explore first? So here priority will be given to the node which is having the minimum evaluation function or straight line distance. So if you see B, C and D, which one is having lowest? 25, then 32, then 35. So C will be explored first, then B, then D. So here in the open list, A will be taken out and kept in closed list, and what will be there in open list? C, D, sorry, C, B, D. So here we will write C, comma, B, comma, D. So these are the nodes that will be present in open list. Now in the next step, we are going to take out C, node C, and put it in the, that is, we always take out the first node. Okay, so why first node? Because this is a queue, right? So A is already there. Now we will take out C and put it in the closed list. Now if we take out C, who are the neighbors of C? A, D, F and E. D is already present in open list. A is already present in closed list. So only E and F left. Now which one, what is the order in which E and F will be added? F will be added first because it is having lower value, and then E. So F will be added first and then E will be added, then B and D already present. So this is our open list. Now in the next step, so in the next step we need to take out F. So we will take out F and put it in the closed list. Okay, so this is F. Okay. So this is F. So now we need to write down, see the children of F. So neighbors of F are C, D and G. C already explored, D already explored, only G left. So now we are just going to take out, we are going to put G here, and then rest already here. So the moment we, so now here we will take out G. Now we are not going to explore anymore, because the moment I keep G in the closed loop, closed list, we will see that I have reached the goal node. So we are not going to explore node G any further. So at this point we are going to stop. So here in the open list, A, B, D will be left out. Okay, so now this is the path that we will consider in order to explore the path that is taken using BFS. So what is the path? A, C, F and G. Okay. So A, C, F and G. So this is the path.